Good morning, everyone. So, today we will be dealing with the problems related to neutralization and nitration. First, we will start with the problems related to nitration. So, the first problem, what is that we are going to see today is please note down the problem. Picric acid is obtained. Picric acid is obtained by nitrating phenol according to the reaction C6H5OH plus 3HNO3 gives C6H2OH NO2 thrice plus 3H2O. So, in a particular operation, 100 kg of phenol was reacted with 250 kg of nitric acid to produce 200 kg of picric acid. What is the limiting reactant? What is the conversion of the reaction? Find the composition of the product stream by weight percentage and mole percentage. So once again I repeat, picric acid is obtained by nitrating phenol according to the reaction C6H5OH plus 3HNO3 gives C6H2OH NO2 thrice plus 3H2O. In a particular operation, 100 kg of phenol was reacted with 250 kg of nitric acid to produce 200 kgs of picric acid. What is the limiting reactant? What is the conversion of the reaction? Find the composition of the product stream by weight and mole percentage. So what is given here is given they have given a nitration reaction, that is phenol reacts with nitric acid to give picric acid and water. So here the quantity of the phenol, nitric acid and picric acid is being given. So the phenol quantity is being given as 100 kgs and the nitric acid quantity is being given as 250 kgs, and then the picric acid produced is given as 200 kgs. So now we have to find out of these two reactants, that is phenol and nitric acid, which is the limiting and which is the excess. As you people know, the amount which is present in less, okay, will be the limiting reactant, and the amount which will be present in more will be the excess reactant. By seeing the problem only we can say which is the limiting, that is phenol and nitric acid will be the phenol will be the limiting reactant and the nitric acid will be the excess reactant. But we should prove this. Okay, how we can prove this? By writing the relationship between the reactants, that is phenol and nitric acid. So by writing the relationship between the reactants, we can find which will be the limiting reactant and which will be the excess reactant, as well as once the limiting reactant is found. So since here they have not asked specifically which conversion of what, but they have given us conversion of the reaction. Okay, so if they generally give us like usually when we do the problems they will be giving us like conversion of some compound, either like phenol or nitric acid, like that they will be giving. But here they are not given anything, they have given just like that what is the conversion of the reaction. So that even the problem is being given like that, so where there are two reactants, that is limiting reactants and excess reactants. So generally, if it is given, we should consider the conversion of the limiting reactant. So in the first step, we should find which is the limiting reactant and excess reactant. And in the next step, after finding the limiting and excess reactant, we should find the conversion of the limiting reactant. And then we have to find the composition of the product stream by weight percentage and mole percentage, as like we should find the amount of picric acid produced, the amount of water produced, and the amount of phenol unreacted, and the amount of nitric acid unreacted, and we have to find the weight percentage and mole percentage. So we will start with solving the problems. So first let us write the equation. So what is the equation is C6H5OH plus 3HNO3 gives C6H2OH NO2 thrice plus 3H2O. So first immediately we will find the molecular weights because this quantity is being given in kgs. So if you are writing the relationship, we want the quantities in kgs. So here the molecular weight will be 94. Just calculate, cross verify. Okay, 3 times of nitric acid and picric acid is 223 times of water is 54. So now, as I told, first we will write the relationship between the reactants. So 1 kilomole of phenol is equivalent to 3 kilomoles of nitric acid. Okay, so now since the quantity is being given in weight, we have to convert this into weight. So first we should write the molecular weights first. 94 kilomole of phenol is equivalent to 180, sorry, not kilomole, 94 kg of phenol is equal to 189 kgs of nitric acid. So now given is 100 kgs of phenol. This is given in the problem. So for 100 kgs of phenol, you will be getting 100 into 189 divided by 94. So you will be having 201.06 kg. This is what? Theoretical requirement of HNO3, right? Theoretical requirement of HNO3. So, as per the problem, it is given that 250 kgs of nitric acid is being used, but the actual requirement is only 201.06 kgs. So, from this, we can come to a conclusion that is limiting reactant is phenol and the excess reactant is what? Nitric acid. So now we have found which is the limiting reactant and which is the excess reactant. Now the next is we have to find the percentage conversion. As I told, we have to find the percentage conversion of what? Limiting reactant. So here the limiting reactant is phenol. So what is the formula for phenol? Sorry, limiting reactant. Sorry, percentage conversion. Phenol reacted. Okay, phenol reacted divided by phenol in feed into 100. Phenol in feed into 100. Okay, so now phenol in feed we know, but we should know how much amount of phenol is reacted. For that, we should write the relationship between picric acid and phenol. We know how much amount of picric acid is produced, so we should write the relationship between picric acid and phenol, means out of 100 kgs of phenol, how much is reacted, we will be coming to know. So first now we should write the relationship between picric acid and phenol. So 1:1 relationship. So here 1 kilomole of, I am writing in short ways, picric acid is equivalent to 1 kilomole of phenol. Okay. So now how many, first we will write with respect to molecular weights. 229 kgs of picric acid is equal to 94 kgs of phenol. This is as per the equation, relation. Okay, equation. So now given is for 200 kgs. So therefore for 200 kgs of picric acid, we will be having 200 into 94 divided by 229. So you will be having 82.1 kgs of phenol reacted. Okay, so now we have found the phenol reacted. So now we can find the percentage conversion. So what is the formula for percentage conversion? Picric acid, sorry, phenol reacted divided by phenol in feed. Phenol reacted is 82.1. Phenol in feed is 100 into 100. So the percentage conversion is 82.1 percentage. So now we have to find the weight and mole percentage of the weight percentage and mole percentage of the components leaving the reactors. So what are all the components leaving the reactor here? First will be the products, right? First will be the products, that is picric acid and water. Along with this, you will be having unreacted phenol and unreacted nitric acid. You people know, right? Already so many problems we have solved. This will be unreacted. Okay, so picric acid produced we know, okay, but we don't know the amount of picric acid produced. Sorry, picric acid produced is being given, that is what, 200 kgs is being given in problem. But water produced quantity is not given. This we have to find. Phenol reacted we know, we have to find that, as well as HNO3 unreacted also we have to find. Okay, so now to find the water produced, we have to write the relationship between phenol and water. Okay, phenol and water. So we will write the relationship. So 1 kilomole of phenol is equivalent to 3 kilomole of water. Always reactants to products. Okay, this is the limiting reactant, right? So we are writing the relationship between limiting reactant and products. So as per the relationship per molecular weight, 94 kg of phenol is equivalent to 54 kgs of water. Okay. Now, how much amount of phenol is being reacted? 82.1. Already we have found. So, for 82.1 kgs of phenol, you will be having 82.1 into 54 divided by 94. So, you will be having 46.16 kgs of water produced. So now water produced we know, and then what? Water produced we know, and then we know the picric acid produced also. Now we have to find the phenol unreacted and nitric acid unreacted. So for this phenol unreacted, we have to write the material balance of phenol. Already we have found the phenol in feed and phenol reacted, so we can find the phenol unreacted. So now write the material balance of phenol. Okay, material balance of phenol. So that is phenol charged is equal to phenol reacted plus phenol unreacted. Okay, phenol charged is equal to phenol reacted plus phenol unreacted. So phenol charged is 100, phenol reacted is 82.1. So that phenol unreacted will be, therefore phenol unreacted is equal to 100 minus 82.1, you will get us 17.9 kgs. Okay, next is we have to find the nitric acid unreacted. So for that, first we should know nitric acid reacted. So for that, you should write the relationship between product and reactant. Okay, so we will write the relationship between picric acid and nitric acid. So 1 kilomole of picric acid is equivalent to 1 kilomole of nitric acid. Okay. So now as per molecular weight, 229 kgs of picric acid is equivalent to 189 kgs of 189 kgs of nitric acid. So therefore, for given is how much? 200 kgs of picric acid. So the given is 200 kgs of picric acid will be equivalent to 200 into 189 divided by 229. So the answer will be 165.07 kgs of nitric acid. This is what reacted. Okay, this is what reacted. Now we have to write the material balance of nitric acid so that we can find the amount of nitric acid unreacted. That is nitric acid charged is equal to nitric acid charged is equal to nitric acid reacted plus nitric acid unreacted. Okay, nitric acid unreacted. So nitric acid charged will be what given in the problem already. It is 250 is equal to 165.07 plus nitric acid unreacted. Okay, so from this we can find nitric acid unreacted is equal to 250 minus 165.07. You will be getting 84.93 kgs. 84.93 kgs. So now we have found all the things. So now we have to find the weight percentage and mole percentage. So first let us write the component, and we have found the quantity in weight, that is kgs. Okay. So first let us write the component. So first is what? Picric acid, and the second is phenol. Okay, these are picric acid is product, phenol is okay unreacted reactant, and the next is water product. Okay, and one more unreacted reactant is nitric acid. So the quantities produced are already we have found, that is 200, 17.90, 47.16, and then what? 84.93. So now next is we have to find the weight percentage. So if you are writing in the tabular form, it will be easy. Okay. So 349.99. So 200 divided by 349.99 into 100, you will be getting 57.14, 5.11, 13.47, 24.27. So the total you will get is 99.99. So the thing is, the next thing is, they have not just asked only to find the weight percentage, they have asked us also to find the mole percentage. So how we can find the mole percentages? If you know the moles of the quantities only, we can find the mole percentage. Okay. So for that, first you should know what is the formula for finding the mole is weight by molecular weight. So if you know weight already, we know. If you know the molecular weight, we can find the mole first and then we can find the mole percentage. So for symbol, first we will write the molecular weight. Okay. So that is molecular weight. Already we have found this also. 229, 94, 18, and 63. Just the molecular weight. Okay. 229, 94, 18, and 63. So here you should write there with respect to what? The quantities. That is, in the problem, in the equation, we have written with respect to 3 molecules of H2O, 3 molecules of nitric acid. So here just we have to write the molecular weight, not with the number of moles as per the thing. Okay, that is the difference between that previous molecular weight in the equation and this. Okay, and the next is mole. The formula is weight by molecular weight. We know the weight as well as we know the molecular weight. So we can find that is 200 divided by 229. So like that we can find the moles. So you will be getting 0.190, 2.620, 1.248. Okay. And the total will be of 4.931. And then we have to find the mole percentage. You people know the mole percentage, right? That is moles by total moles. So you will be getting the percentage as 17.70, 3.85, 53.13, and 25.31. The total what you will get is 99.99. So this is all about this problem. So first we have found the limiting reactant and excess reactant, and then we have found the percentage conversion of limiting reactant, and then we have found the produced unreacted, all these and all, and then we have found the mole percentage and weight percentage. Okay, so let us go. So I hope all of you have understood this problem. Let us go to the next problem. Okay, the next problem is toluene reacts with nitric acid. So this is also the one of the problem of nitration. So toluene reacts with nitric acid to form orthonitrotoluene and water, and after carrying out the nitration operation, which can be represented by the equation C6H5CH3 plus HNO3 gives C6H4CH3NO2 plus H2O. The product mixture was analyzed and found to contain 75% orthonitrotoluene, 10% water, and 15% nitric acid by weight. Comment about the conversation of the reaction. What is the percentage excess of the reactant used, and what is the quantity of the toluene used for the reaction? Once again, I repeat, toluene reacts with nitric acid to form orthonitrotoluene and water. After carrying out the nitration operation, which can be represented by the equation C6H5CH3 plus HNO3 gives C6H4CH3NO2 plus H2O. The product mixture was analyzed and found to contain 75% orthonitrotoluene, 10% water, 15% nitric acid by weight. Comment about the conversation of the reaction, and what is the percentage excess of the reactant used, and what is the quantity of toluene used for the reaction. So here again it is a nitration reaction. So here toluene reacts with nitric acid to give orthonitrotoluene and water. So now they have given the final composition, that is product, the mixture was analyzed to contain 75% orthonitrotoluene, that is orthonitrotoluene produced, 10% water, that is water produced, and 15% nitric acid by weight, that is the unreacted nitric acid. So now we have to find the conversion of the reaction, as well as what is the percentage excess of the reactant used, and what is the quantity of the toluene used for the reaction. All this we have to find. Okay. So Let us start with the problem. So the basis we will take it as, since it is present in given in the weight percentage, we will take the basis as 100 kg of product. Okay, 100 kg of product. So here, what is the another one thing we should consider is, in the product stream they have not mentioned anything about the toluene. That means the conversion of the toluene is what? 100 percentage. Clear? So they have given only the nitric acid is present, the product stream. Along with the product, only the nitric acid is present. The toluene is not present. That means 100 percentage of toluene is reacted, so that toluene will be the limiting reactant. Toluene will be the limiting reactant. Okay. So now we have to find how much will be this percentage excess of nitric acid. If we have to find, means nitric acid, you people know the formula, so accordingly we have to find the percentage excess. So for that, first we will write the relationship between nitric acid and toluene. Okay, so now first we will write the relationship. So 1 kilomole of nitric acid is equivalent to 1 kilomole of orthonitrotoluene, and you should know the molecular weights. Okay, so now already I have written here in this. So molecular weight of nitric acid is 63 and molecular weight of toluene is 137. Okay, so according to molecular weights, so for 63 kgs of nitric acid, you will be having 137 kgs of orthonitro toluene. Okay, so already this orthonitrotoluene quantity is given. So as usual, we have to write the known quantities on the left hand side. So 137 kgs of orthonitrotoluene is equal to 63 kgs of nitric acid. So now given is how much kgs of orthonitrotoluene? 75 percentage. So that means in kgs you will be writing as 75 kgs. So the 75 for 75 kgs of orthonitrotoluene, you will be giving 75 into 63 divided by 137. So you will be having 34.49 kgs of nitric acid is reacted. Nitric acid is reacted. Okay. So now we have to find the nitric acid unreacted, because the percentage formula is what? Nitric acid in charge minus nitric acid reacted by nitric acid reacted into 100 will give you the percentage excess, right? So they have given in the equation, in the problem, HNO3 unreacted is what? 15 kgs. That is 15 percentage they have given, so it will be 15 kgs. So nitric acid in feed will be nitric acid reacted plus nitric acid unreacted. So this plus this will give you what? Nitric acid reacted is how much? 34.49. The nitric acid unreacted is what? 15. So you will get as 49.49 kgs. This will be the amount of nitric acid in feed. So now percentage excess nitric acid will be equal to 49.49 minus 34.49 divided by 34.49 into 100, divided by 34.49 into 100. So you will be getting the answer as 43.49 percentage. You will be getting the answer as 43 point. This is the percentage excess. Okay, and you have to find how much amount of toluene we have to find how much amount of toluene is being present. Okay, so quantity of toluene is also asked, so we have to write the equation relationship between orthonitrotoluene and toluene. Okay, so 1 kilomole of orthonitrotoluene is equivalent to 1 kilomole of toluene. Okay, so now as per the molecular weight, 137 kgs of orthonitrotoluene is equivalent to 92 kgs of toluene. Okay, so now given is how much kgs of orthonitrotoluene is produced? 75 kgs of orthonitrotoluene is produced. So you will be having 75 into 92 by 137. you will be having as 50.36 kgs of toluene is being used, okay, or reacted. Okay, this is what the answer. So percentage excess they have asked, and as well as the percentage amount of toluene reacted. So these both quantities is been found now. Is it clear? So I will go to the next problem. So the next problem is acetylene is produced according to the following reaction, that is calcium carbide reacts with water to give you calcium uh, acetylide, okay, and calcium acetylide and calcium hydroxide. And if 100 liter of gas is burnt per hour at 298 kelvin and 98.68 kilopascal pressure, calculate the amount of CaC2 in kgs, which must be used in the acetylene lamp at the above temperature and pressure to get 15 hours of service of the lamp. CaC2 reacts to give acetylene gas to burn in the lamp. So once again I repeat. So acetylene is produced, okay, that is C2H2 is produced by the according to the following reaction, that is calcium carbide reacts with water to give you acetylene and calcium hydroxide. If 100 liters of gas is burnt per hour at 298 Kelvin and 98.68 kilopascal pressure, we have to calculate the amount of calcium carbide in kgs, which must be used in the acetylene lamp at the above temperature and pressure to get 15 hours of service of the lamp. Calcium carbide reacts to give acetylene gas to burn in the lab. Okay. So now they have given the reaction. So they have given 100 liters of gases burned per hour. Okay, they have given the temperature and pressure. We have to, for 100 liters of gas to burn per hour, we have to find the calcium carbide in kgs. Okay, so then we have to find for 1 hour is 100 liter of gas. For 15 hours, how much has been reacted to give acetylene gas is what we have to find. So now let us uh, start with the problem. So given data basis given is they have asked us to find for 15 hours of operation. Okay, for 15 hours of operation they have asked us to find. But the burning rate of acetylene as per the given as per the given data is, they have given very clearly 100 liter of gases burnt per hour. So per hour it is what, 100 liter per hour. Okay, so now acetylene gas burnt for 15 hours will be 100 into 15. So you will be getting 1500 liter. Okay. So now we can write C2H2 generated. How much ever acetylene gas is produced, that will be burnt. Okay. So it is not like that we are adding extra. How much is produced only, it will be burned. So C2H2 generated will be equal to C2H2 burnt, that will be equal to 1500 liters. This is for 15 hours. Okay, so now we have to find the moles of C2H2 gas, which will be corresponding to 1500 liters. So the formula is PV is equal to nRT. Okay, PV is equal to nRT. So N will be equal to PV by RT for finding the number of moles. Because here pressure, temperature and volume, all this we know, we have to use this formula. So moles of C2H2 gas corresponding to corresponding to 1500 liter will be equal to PV by RT. So pressure is given as 98.68 and the volume is 1500 divided by R is 8.314 and the temperature is 298. So you will be getting the answer as 59.74 mole. So now this is what the number of moles of C2H2. Number of moles of C2H2. Okay. Now the reaction what we have is CaC2 plus 2H2O gives C2H2 plus CaOH CaOH twice. Okay, so now we should know how much amount of C2H2 is reacted. Okay, CaC2 is reacted. For that, we should write the relationship between C2H2 and CaC2. Okay, so now 1 mole of C2H2 is equivalent to 1 mole of CaC2. Okay, 1 mole of CaC2. Okay, 1 mole of C2H2 is equivalent to 1 mole of CaC2. Okay, therefore, for given 59.74 mole of C2H2, how much will be there is 59.1 is to 1 relation, 59.74 into 1 into 1. So you will be getting as like 59.74 moles of C2H2 reacted. Okay, 59.74 moles of C2H2 reacted. Is it clear? So first, by means of using this volume, all this, we have found the number of C2H2, okay, acetylene gas produced and for 1500 liters. Okay, now from that we have found how much amount of C2H2 is reacted. So now the C2, sorry, C2Ca, not C2H2, CaC2 reacted. Okay, calcium carbide reacted. Okay, calcium carbide reacted. But they have asked us the quantities in molecular weights. So moles into molecular weight, so in kgs. So moles into molecular weight will give you the answer in kgs, right? So multiply with molecular weight. So molecular weight of CaC2 will be equal to 64. 64. So the weight of CaC2 required is equal to 59.74 into 64. So you will be getting as 3823 grams, because it is in moles, we are getting in grams. So this will be equal to 3.823 kgs. Okay, when you are converting it in kgs, you will be getting is. So once again, I repeat this problem. They have given acetylene, that is C2H2, is being produced according to the following reaction, that is calcium carbide reacts with water to give you acetylene and calcium hydroxide. So they have given if 100 liters of gas is burned per hour. So per hour, so C2H2 ethylene, that is ethylene gas, acetylene gas will be burning rate is 100 liters per hour. The temperature will be 298 Kelvin and the pressure is 98.68 kilopascal. Now we have to find, for this we have to find how much amount of calcium carbide has been reacted, and then for calcium carbide reacted for 15 hours of service for 1 hour 100 liters. So same way, for 15 hours of acetylene gas to be burned, how much amount of calcium carbide is required is what has been given in the problem. So 15 hours of operation is our basis. So burning rate of acetylene is 100 liters per hour. So the acetylene gas burned for 15 hours will be 100 into 100 liters per hour into 15 hours. 15 hours. Okay. So har will get cancelled. So it will get 1500 liters. So as we know, what how much amount of acetylene generated only will be equal to acetylene burned. So you will be having C2H2 generated will be equal to C2H2 burned is equal to 1500 liter. So we should know the number of moles, because we cannot find directly the weight. Only possible clue here is pressure and volume. So we have taken the PV is equal to nRT relationship, and we have found the number of moles of what C2H2 gas corresponding to 1500 liter. And then we have write the relationship between C2H2 and CaC2, and then we have found the moles of CaC2 reacted, and from that we have found the weight of CaC2. Okay, this is all about this problem. And the next problem here is 100 kilomole. Okay, 100 kilomole of ethyl acetate is charged and hydrolyzed to produce ethyl alcohol and acetic acid. The product stream is found to contain 45 kilomole ethyl alcohol. What is the conversion and what will be the amount of acetic acid produced? Same very simple problem. So they have given 100 kilomole of ethyl acetate is charged and hydrolyzed. Hydrolysis. So reaction, not neutralize nitration. This is a hydrolysis reaction. So this will be giving you ethyl alcohol and acetic acid as the product. And the product stream you are having for 45 kilomole of ethyl alcohol. So now we have to find the conversion and as well as the what will be the amount of acetic acid. So first let us write the basis. So basis here is 100 kilomole of ethyl acetate. Okay, 100 kilomole of ethyl acetate. So we have to write the reaction. So ethyl acetate reacts with hydrolysis, right? Water to give you ethyl alcohol. Formula is C2H5OH plus CH3COH. Okay, so ethyl acetate molecular weight, ethyl acetate molecular weight is 88, water molecular weight is 18, ethyl alcohol, okay, this is ethyl alcohol. Ethyl alcohol molecular weight is 46 and the acetic acid weight is what? Acetic acid weight is 60. Okay, so now they have given us kilomole of ethyl alcohol produced, kilomole of ethyl alcohol produced is equal to 45 kilomoles. Okay, they have given us 45 kilomoles of ethyl alcohol is produced. Okay, so now we write the relationship between ethyl acetate and ethyl alcohol. Sorry, ethyl alcohol and ethyl acetate. You will know how much amount of ethyl acetate reacted. So write it. So 1 kilomole of ethyl alcohol. Okay, 1 kilomole of ethyl alcohol is equivalent to 1 kilomole of ethyl acetate. 1 kilomole of ethyl acetate. Okay, so now given us how much? 44, 45, therefore for 45 kilomole of ethyl alcohol you will be having 45 into 1 is to 1 relationship. So you will be having 45 kilomole of ethyl acetate reacted. 45 kilomole of ethyl acetate reacted. Okay, so now percentage conversion. So here you have to percentage conversion means main reactant only we have to take. So percentage conversion of ethyl acetate, percentage conversion of ethyl acetate will be ethyl acetate reacted. Okay, ethyl acetate reacted divided by ethyl acetate charged. Okay, ethyl acetate charged into 100. Ethyl acetate charged into 100, that is ethyl acetate reacted is 45, ethyl acetate charged is 100. So 45 by 100 into 100, that will be equal to 45 percentage. So percentage conversion is done. So they have asked us to find the kilomole of acetic acid produced also. They have asked us to find. So now we know how much amount of ethyl acetate reacted. So if you write the relationship between ethyl acetate reacted and acetic acid, you can find how much amount of this is produced. So that is 1 kilomole of ethyl acetate. 1 kilomole of ethyl acetate is equivalent to 1 kilomole of acetic acid. Okay, 1 kilomole of ethyl acetate is equivalent to 1 kilomole of acetic acid. Therefore, for 45 kilomole of ethyl acetate, you will be having 45 into 1 by 1, that is 45 kilomole of acetic acid produced. So this is the two data they have asked, very simple problem. Okay, so write the relationship and then find the conversion. Usually conversion always will be for the main reactant, conversion will be for the reactants only, not for the product. So if it is not given specifically, as I told, we have to write either for the limiting reactant or for the main reactant. So here the main reactant is ethyl acetate. So we have written and afterwards we have wrote the relationship and find this. Okay. And the next concept is neutralization. So, what do you mean by neutralization? Is the reactions taking place between and acid and alkali. Okay. So, when there is a reaction taking place between and acid and alkali, the product what we are getting will be in the form of salt, and the reaction taking place will be what? The reactions taking place between the acid and the alkali will be called as the neutralization reaction. Acid and alkali will be called as the neutralization reaction. So now we will see the problems related to neutralization. Okay, so two more problems with related to neutralization, simple problems, we will do that. Okay, so the problems are 100 kgs of hydrochloric acid is neutralized by 150 kgs of NaOH. What is the quantity of sodium chloride that will be produced? Find the composition of the neutralized mixture by weight and mole. Okay, so once again I repeat, so 100 kgs of hydrochloric acid is neutralized by 150 kgs of NaOH. What is the quantity of sodium chloride that will be produced? And find the composition of the neutralized mixture by weight and mole percentage. So we are having here hydrochloric acid, that is an acid, and we are having an NaOH, that is alkali. So now this will be reacted to give you what? Sodium chloride. Okay, so now we have to find the composition of the neutralized, that is analysis we have to do. So for that, first we should write the relation. So HCl, hydrochloric acid, plus NaOH gives sodium chloride, that is NaCl plus water. This will be the reaction, neutralization reaction. So since it is given in weights, we want the molecular weights. So molecular weight of this is 40, this is 58.5, and so we have to find the quantity of sodium chloride produced and the composition of the neutralized mixture and weight and mole. That means what? NaCl we have to find. Okay, NaCl, H2O will be the products. Along with that, we have to find the, just a second, NaOH, NaCl is the product, H2O is the thing, and then we have to find the amount of HCl, H2, sorry, unreacted HCl and unreacted NaOH also. Okay, all these things we have to find. Okay, so now first we will write with the relationship and find how much amount is reacted and all. So now 1 kilomole of HCl, first we will write for the relation between the reactants. 1 kilomole of HCl is equivalent to 1 kilomole, for the reactants we will write 1 kilomole of NaOH. So now therefore for 36.5 kgs of HCl we will be having 40 kg of NaOH. 40 kg of NaOH. So given is how much? This is as per relation. Therefore, for 100 kgs of HCl, you will be having 100 into 40 divided by 36.5. So that is 109.59 kgs. Okay. So 109.59 kgs. So given quantity of NaOH is what? 150 kgs. So, but the amount of NaOH reacted is how much? 105, 109.59 kgs. So, NaOH is the excess reactant and HCl will be the limiting reactant. So, here what happens is these two are products. Along with that, only the excess reactant will present. That is, only the NaOH will present. Okay, so the limiting reactant will be completely reacted. So we have to find the amount of NaCl produced, water produced, and the amount of NaOH unreacted, that is excess reactant. Okay, so for finding the relationship between amount of NaCl produced, we have to write the relationship between HCl and NaCl. So 1 kilomole of HCl is equivalent to 1 kilomole of NaCl. Okay, therefore we have to write the molecular weight. 36.5 kgs of HCl is equivalent to 58.5 kgs of NaCl. So that will be, therefore for given 100 kgs, it is given 100 kgs of HCl, you will be having 100 into 58.5 divided by 36.5, that is equal to 160.27 kgs of NaCl produced. Okay, NaCl produced. Okay, so This is NaCl produced this done. Then we have to write the relationship between same way HCl and H2O. You will come to know how much amount of H2O is produced. So now the next is 1 kilomole of HCl is equivalent to 1 kilomole of H2O. Okay. So you will be having therefore 36.5 kgs of HCl is equivalent to 18 kgs of water. Okay, so you will be having therefore for given is 100 kgs of HCl, you will be having 100 into 18 divided by 36.5, you will be having 49.59 kgs of this will be water produced. 49.59 kgs of water produced. Okay, so now water produced is done and then NaCl produced is done. We have to find the NaOH unreacted. So material balance of NaOH we have to write. Okay, that is NaOH in feed is equal to NaOH reacted plus NaOH unreacted. So that is 150 is equal to, we know that NaOH 109.59 plus NaOH unreacted. So NaOH unreacted will be equal to 40.41 kgs. Okay, so now we have found all the quantities. We have to find the weight percentage and mole percentage and all. So we will write as component. Okay, then weight, then weight percentage they have asked in both. Then next we have to write the molecular weight and then mole, and then we have to find the mole percentage. Clear? So first we will write NaOH. Okay, then we will write first NaCl. Okay, then NaOH, then water. Okay, so NaCl it is 160.27, NaOH is 40.41, and this will be 49.59. The total weight is 250. Just cross verify. Okay, this will be 64.11, 16.16, 19.73. The whole. So the molecular weight will be 58.5. Okay, 40 and then 18. So mole will be, you people know, weight by molecular weight 2.74, 1.01, 2.74 again. Okay, so this will be 6.49. So 15.56, 42.22, 42.22. 42.22. So the total you should get as 100. The total you should get as 100. Okay, so this is all about this problem. So one more problem is there in this module. With that the module will be completed. So I will finish that problem and then we will see. So the problem is ammonium hydroxide is used. Ammonium hydroxide is used for neutralizing acetic acid according to the reaction. CH3COOH plus NH4OH gives CH3COO NH4 plus water. If the 120 kg of acetic acid is to be neutralized, what will be the quantity of ammonium hydroxide required? If 25 percentage excess NH4OH is used and if the reaction is 90 percentage complete, what will be the composition of the product stream? So once again I repeat, ammonium hydroxide is used for neutralizing acetic acid according to the reaction. CH3COOH plus NH4OH gives CH3COO NH4 plus H2O. If 120 kgs of acetic acid is to be neutralized, what will be the quantity of ammonium hydroxide required? If 25 percentage excess NH4OH is used and if the reaction is 90 percentage complete, what will be the composition of the product stream? Okay, we have to find the composition of the product stream. So same as like the previous problem, so many problems we have solved, but this is the neutralization problem, that's all. First we will write the relationship. CH3COOH plus NH4OH gives CH3COO NH4 plus H2O. Okay, so now the molecular weights are 60, 35, 77, and 18. Okay, so now first we will write the relationship between COOH, this and this. Okay, so now ammonium acetate and then CH3CO acetic acid, and this is called as ammonium acetate. Okay, ammonium acetate, ammonium acetate. So now 1 kilomole of CH3 COOH is equivalent to 1 kilomole of NH4OH. Okay. Therefore, for according to weight, 60 kgs of CH3 COOH is equivalent to 35 kgs of NH4OH. Okay. So given us 120 kgs of CH3OH. Okay. Therefore, for 120 kgs of CH3OH, you will be getting 120 into 35 by 60. So you will be getting 70 kgs of NH4OH required. Okay, this is theoretical requirement. So now they have asked, so they have given the percentage excess. So we know the theoretical requirement. So from this we can find the NH4OH supplied. Okay, NH4OH supplied. Okay. So first we have written the relationship between the reactants to find the NH4OH supplied. So NH4OH theoretical requirement into 1 plus percentage excess divided by 100. So NH4OH supplied is equal to 70 into 1 plus 25 divided by 100. So you will be having as 87.5 kgs. This is supplied. Okay, this is supplied. And the next they have given us reaction is 90 percentage complete. Okay, next condition they have given us reaction is 90 percentage complete. Okay, reaction is 90 percentage. Therefore, acetic acid reacted will be, so given us what, 120 kgs, in this reacted is 90 percentage. So 120 into 90 by 100. So you will be having 108 kgs. The next is we can write the material balance of acetic acid so that we can find the acetic acid unreacted. Okay. So acetic acid in feed is equal to acetic acid reacted plus acetic acid unreacted. Okay, so therefore acetic acid and feed in feed is what, 120, this is what, 108 plus acetic acid unreacted. So acetic acid unreacted will be 120 minus 108, that will be equal to 12 kgs. Okay, so now we have to find how much amount of NH4 theoretical requirement of NH4OH we know. Now we should know how much amount of NH4OH reacted. Okay. So for that you should write the relationship between acetic acid and NH4OH. Okay. 1 kilomole of NH4OH. Okay. Theoretical requirement, from theoretical requirement we have found supplied. So now we have to find how much is reacted. So for 60 kgs of acetic acid, you will be having 35 kgs of, this is as per molecular weight, NH4OH. Okay. So now therefore for 108, okay, 108 kgs of acetic acid, you will be having 108 into 35 divided by 60. So you will be getting as 63 kgs of NH4OH reacted. Okay, so we have found the NH4OH reacted. Now we know NH4OH is feed, NH4OH reacted, so we can find the NH4OH unreacted. So write the material balance of NH4OH and find the NH4OH unreacted. So NH4OH unreacted will be equal to 87.5 minus 63. You people know, right, material balance. NH4OH in feed is equal to NH4OH reacted plus NH4OH unreacted. Okay. So that will be equal to 24.5 kgs. Okay. So now we should know how much amount of ammonium acetate and H2O produced. So unreacteds we had found. Now produced we have to find. Okay. So now write the relationship between reactant and products. So 1 kilomole of acetic acid will be equivalent to 1 kilomole of ammonium acetate. Okay, ammonium acetate. Therefore, as per the relation equation, 60 kgs of acetic acid is equivalent to 77 kgs of ammonium acetate. Okay, so now given how much amount of acetic acid reacted is 108 kgs, you will be having 108 into 77 divided by 60. So you will be having as 138.6 kgs of ammonium acetate produced. Okay, same way you have to find how much amount of water produced. So 1 kilomole of ammonium acetic acid is equal to 1 kilomole of water. Okay, so you will be having for 60 kgs of acetic acid is equivalent to 18 kgs of water. So now for the given, for the reacted 108 kgs of acetic acid is equal to 108 into 18 by 60, that will be equal to 32.4 kgs of water produced. 32.4 kgs of water produced. Okay, so now we have found all the unreacted and the amount of quantities produced. So we have to find now the component, then weight and weight percentage. Okay, component, then weight percentage, component, weight and weight percentage. Acetic acid and ammonium hydroxide or the unreacted reactants. Okay, ammonium hydroxide, all these are unreacted reactants. Sorry, acetic acid is the just a second. Acetic acid is the unreacted reactant. Ammonium hydroxide is the unreacted reactant. And then these are unreacted reactants and ammonium acetate. Okay, ammonium acetate and water or the products produced. So we have found the weights 12, 24.5, 138.6, 32.4. The total will be 207.5 and the weight percentage will be 5.78, 11.81, 66.80 and 15.61. The total will be 100. So same, nothing different and all. Just we have to write the relationship and we have to find the analysis. Mole percent weights of the products and as well as the weights of the unreacted reactants. So with this, the module 2, 3 is completed. Next class, I will be starting with the module